Hello. Thank you for joining us today for our webinar on advancement of water quality initiatives through monitoring, analytics, and mitigation. I'm Billy Emis. I'm a sales associate here at AWWA, and I will be your moderator for today's webinar. Here are some tips to enhance your webinar experience. We recommend that you close email, instant messengers, and any other programs not currently in use, as they may interfere with the smooth reception of the webinar, causing slide buffering and poor sound quality. Technical assistance can be found at the GoToWebinar technical support page at the link listed in your handouts and on the slide shown. As soon as you close the GoToWebinar screen, to leave the webinar, a window will open with a survey questionnaire. We ask that all of you take a few minutes to answer the survey questions. Your feedback is important to us and helps us improve programming throughout the webinars. Before we hear from our speakers, I need to inform you that the mention of specific products or services in this webinar does not represent AWWA endorsement. AWWA does not endorse or approve products or services. I'm pleased to introduce our distinguished panel of experts for today's webinar. Tim Rule, a product line leader for Mueller, Harold Mosley, a product brand manager at HydroGuard, and Chris Stanton, the Utility Compliance Superintendent for the City of Plano, Texas. Our panel will be happy to answer your questions. Please feel free to submit questions at any time throughout this broadcast by using the question pane at the lower right of your screen. Please include the name of the panelist to whom your question should be directed. Let's begin. Take it away, Tim.
Thank you, Billy, for kicking us off, and good afternoon, everyone. My name is Tim Rule, a product line leader for Mueller Water Products. I joined the water industry and Mueller after spending 20 years in building consumer devices and intelligent cloud platforms for other industries. The water industry is a great community to be a part of, and with lots of knowledge sharing across professionals. In that spirit, I'll be moderating this panel discussion that includes two water industry experts, as Billy introduced, Harold Mosley and Chris Stanton. Today, we will learn from our water specialists how to maintain compliance and reduce complaints through automation, to develop a strategy for an automatic flushing program, and finally, we'll learn how data, remote monitoring, and automatic flushing can work together. So we'll kick off our discussion with a question to Harold. Harold is our water specialist expert here at Mueller. Harold, what type of flushing use cases do your clients have to manage?
Well, Tim, there's basically three primary types of flushing categories. There's routine, temporary, and industrial. And routine flushing is simply includes permanent, semi-permanent type flushing systems. These are ideal for locations where it's common to have water quality complaints, or where it's hard to maintain an acceptable disinfectant residual level, or perhaps where water lines are sized for times when potable water was supplied for irrigation and drinking, but now with reuse being used more for irrigation, the demand has been reduced. With the temporary option or flushing solution, it involves using automation to flush fire hydrants throughout the distribution network. This practice allows you to pinpoint water where water flushing is required. Perhaps following a water line break, or where new developments are being brought into your utility, but those new developments are not turning water over enough frequently enough. So therefore, you're getting issues related to aging water, such as biofilms and disinfectant byproducts, things of that nature. And then, of course, there's the industrial side of things, which typically includes flushings of small water lines, perhaps manufacturing plants, small distribution water lines at schools, or where eye washes, drinking fountains, safety showers might be present. One utility that I know of uses these types of devices to maintain water quality at a poultry plant, and others use them in university campuses and small RV parks.
Thanks, Harold. So a lot of use cases out there. If you could talk us through some of the discussions that you've had with utilities to identify that right flushing device or a fleet of devices to support their routine flushing needs.
Sure. So typically the first step we take with a utility that we're partnering with is to identify the installation site. And in looking at that installation site, we want to take things into consideration that basically it's important to install the right product for the right location so it can operate at the right time and in the right way. So we want to know what the climate is in that area. You also want to know what is the issue that needs to be addressed. What's the water quality issue that's driving the need for this? You want to know what the size of the water main might be that you're trying to tap and then manage that with that flushing device. And then obviously you want to know, and probably the most important thing you want to know, is how is the community going to be served by this device? It's with new communities installing below grade utilities, it's important to remember that they may not want devices, pedestal enclosures sitting up in their yard. So therefore, perhaps something that's below ground might be of most interest to them, or perhaps it's a situation where your crews need to see have a visual on that water flushing. So therefore, it might be better off to have something that sits above ground where you have a visual of the water flushing down on the ground. You want to consider how you wish to discharge the water being flushed. Do you want to put it on the ground? Do you want to send it to a pond, a swale, or a storm sewer? You also need to take into consideration how much water may be flushed. And there are online flush duration calculators available that you can use to determine how much water you do need to flush by, how frequently do you need to turn that water over. We typically recommend every 72 hours you want to turn water over so it doesn't age and create biofilm issues. And the other thing you need to take into consideration, back to climate, is do you need freeze protection on that flushing system so that you don't freeze up the device itself? And then lastly, you need to know, is time-based flushing going to be acceptable, or do I need to do something more advanced where I need to maybe look at chlorine, temperature, pH, turbidity, flow, pressure, and other parameters such as that in order to understand what's going on in my distribution network.
Thanks, Harold, for the thorough answer. And certainly finding that right flushing device certainly seems to require some upfront planning. And based on your response, it's clearly not a one-size-fits-all solution, even within that single distribution network. So a lot of things for utilities to consider. Could you help us talk through some of those deployment scenarios that are common to automated flushing?
Yeah, I think boiling it down to the most common applications, it usually comes down to residential communities. It comes to, as well as seasonal areas, and then areas where you have limited access, and then your industrial or office parks. Your residential communities, especially new communities, pose a significant challenge for utilities of all sizes, including your rural utilities. These new developments are oftentimes a long ways from your water treatment plant. It takes a long time to get a crew out there. The residential community may not be fully built out, so therefore the water stagnates in the line, and then you start having customers lodging complaints, and complaints are costly. Seasonal areas are of concern as well, because you're building water lines to serve a large population for a very short period of time. And then once that population leaves to go back to wherever they came from, you've got a lot of water standing in those lines that you've got to do something with. You got to be able to turn it over. If you don't turn it over, you start getting the biofilm buildup. That creates disinfectant byproduct issues, or can lead to disinfectant byproduct issues and other water quality conditions. So you need to start turning that water over more frequently. That puts stress on your utility. And then the limited access sites like your airports or seaports and military bases are also hard to manage. Access is limited to those facilities. Many times the owners of those facilities want outsiders on property, but when you do get on property, then you end up typically losing your crew for the whole day. So as far as efficiency, it's rough on efficiency. And your industrial and office parks are challenging to utilities because of the peak and off-peak times. They may not necessarily align with your peak and off-peak times. They also typically want more pressure brought to those sites than what the residential areas around those sites are needing. So that can create issues in your water distribution system as well. And during the COVID shutdowns, many utilities faced significant challenges just maintaining those service lines, especially if they were trying to do it with just sending a crew out to a fire hydrant and trying to turn water over in that way.
All right, so definitely a lot of deployment scenarios, each requiring its unique solution. Very good. Thank you for that overview, Harold. This, I think, would be a good time for us to start with a poll question, our first poll question. Our first poll question is, please select the answer choice that best represents the effort that is required to support your flushing program. Is it A, my program requires minimal people and time to support? Or B, my flushing program requires a crew and too much of my time to support? Or simply, I don't know. So this is a really good poll question to see where the audience is with, on your journey and how much you have considered and looked into automated flushing solutions. So we'll give the audience some time to fill out the questionnaire, and then we'll read off some results here shortly. All right, so let's see here. Looks like a pretty even split across the choices, and with our first answer choice is my program requires minimal people and time to support, closely followed by my program requires a crew and too much time to support, and others still discovering what the flushing program needs. Very good. We'll move on to the next slide. And our next presenter. So now we'll turn our attention to Chris from the city of Plano. And Chris, you have really a great story to tell. I know that, Chris, based on our conversation, a couple weeks ago, that your compliance team has a tremendous amount of responsibility, and your flushing program journey will be very insightful to share with others on this call. So thanks for being here. Why don't we just start out with just the basic facts about the city of Plano water utility and its customers. So how many service connections do you serve at the city of Plano utility?
We've got a little over 85,000 connections and a population of about 280,000 roughly.
And where do you the city of Plano source its water from? Is this a single source, or are you sourcing from wells or a local body, a reservoir? Or are you purchasing water from a wholesaler?
We purchase from a wholesaler. It's North Texas Municipal Water District. They service us and a handful of member cities around the area. But that's who services. We just distribute the water. We don't treat it in any way. All we do is distribute it and maintain our system.
Understand. So when you buy water from a wholesaler like North Texas, what are the factors that are driving your flushing needs at your utility?
Well, you got obvious things. You got the weather. You got pipe type, distance. The water's first got to make it to our system, and then it's got to go from our system out to the far reaches, or from our pump stations to the far reaches. And you can kind of see on that map some of our worst areas, the hardest areas to get that good water to, and keep it fresh.
Yeah, so we can see this this water age map, and this was, as I understood, something that you worked with an engineering consulting team to develop. We see that it identifies some critical areas. What else does this water age map tell us?
Well, the most important thing is the aging part of it. It shows where the water's the oldest, and just because you have an area out far, well, just so you know, our water comes in from the east side of that map, and then it has to make its way all the way out to the west side of that map. So you can see some of the water out far west isn't as old as some of the water over on that east side, but having this system model really helped us focus on the areas we need to focus on, especially in peak flushing times and also during a chlorine maintenance period when they're using a different type of chemical, and we need to know exactly where to go to get that water distributed in the best, most efficient way and fastest way, really.
And is that a chloramine-based system then? Your reference to using different types of disinfectant?
Yes, our provider uses chloramines to treat our water, and then once a year for a 30-day period, they'll switch over to free chlorine, obviously to help with the disinfection byproducts and the biofilms, get that stuff cleaned out, and then they'll switch back to the chloramines after that 30-day maintenance period.
Well, certainly a lot to keep up with. Your mandatory dead end flushing chlorine maintenance program, and also that hot Texas weather. So, you know, that is certainly a lot of responsibilities that your team has. Maybe in this next slide, if you could talk to the group here about, you know, the scale of the flushing programs and your team size, and what they're responsible in doing on a manual flushing program.
Okay, so our team size in the compliance unit is roughly about 16 people when we're fully staffed. Right now we're running at about 10 people, and when we're heavy into flushing, either for the chlorine maintenance period or for our peak flushing because of water quality issues, we're running probably 10 people flushing on a daily basis and sometimes on a 24-hour basis, depending on how bad the water is or how hard it is to turn it over. So we'll have 10 people, obviously 10 vehicles, and then we're flushing 2 to 3 hydrants per person and vehicle. So you can imagine just at 2 hydrants, you got 4 meters, 4 hoses, 4 diffusers, 10 trucks, 10 people, you know, 4 setups per person. So you're looking at a massive amount of equipment to pull that off, and it's taxing. And then you still got your daily, like you said, dead end water main flushing that's state mandated, and we've got over 900 of those that have to be done monthly. So you're pulling team members off to sit on hydrants when they could be doing the state mandated flushing.
So yeah, certainly a lot. Wow, 900 dead end points to manage, crew of 10, and that's a lot of equipment that each one of those crew members need to carry on their truck. So, what are some of those then your benefits that you see automatic flushing program will serve for the city of Plano?
Obviously the staffing issues and equipment costs, which we kind of just went over. Another thing is really the visual impact of having trucks sitting on street corners just rolling water out of a hydrant. You know, seems like endlessly and just wasting water. So some of the units that we've installed, we've direct piped them into the storm drains, and it reduces a lot of phone calls, a lot of questions, and a lot of headaches. But that's another great aspect of them.
And now you can take those other 8 individuals and assign them to some higher priority or other tasks that your compliance team is responsible for taking care of there at the city of Plano. So that's
Right.
really great. And the obviously the community concerns, which Harold spoke to earlier, is certainly something that you know, should be considered when deploying. And it sounds like your team has done a great job thoroughly thinking this through and doing the business case to justify this automatic flushing program at the city of Plano. I really think that, you know, your flushing program is fairly complex, and I can understand how any sort of automation would make your life easier over there at the utility.
Absolutely.
You also mentioned, though, that it's not just the quantity that you are fighting there at the city of Plano, but you actually had at least one particular challenging spot. And in fact, in Harold's intro earlier, this challenging spot was actually at an industrial park. Can you take us through what made that industrial park so difficult for you to manage? And then as a follow-up, just how do you intend to solve that problem?
One of the challenges is that it's so far out. It's probably the furthest away from our entry point, from where we get our water. So that's a challenge in itself. Capacity, the capacity of our water lines it was overbuilt when they built that area back in the day. So we're holding too much water, we're holding it for too long, and it's going too far. So another factor was COVID. When that building went empty, we really struggled this past year to keep up with that water over there. So we flushed a lot over there. It was one of the worst years we had, especially in that area for a high water age. And then we've recently installed 5 flushing devices over there and in specific locations, so we can pull that water not only whenever we want, but also kind of directionally through that complex to keep it fresh.
Now it's my understanding that you've mixed the type of automatic flushers that you're using. You mentioned there's 5 automatic flushers. Are those flushers then running on like a time-based mechanism?
Those are the Bluetooth controlled ones, and we can set them up for whatever length of time we need to run. And I think it's up to 12 or 24 times a day we can run them. And yeah, we do have separate types over there. We've got some that are directly piped into the storm drains. Like I told you earlier, we try to utilize those more than the others, just because of the visual impact. And then we're actually in the process of installing one of the smart units right now over there that actually checks chlorine levels on a constant basis, so that it can alert you when you need to turn that unit on and flush, and you can actually have that unit flush itself when the chlorine levels get to where it needs to start flushing.
Yeah, that's great. So going from a time-based scheduling to event-based, and you as the utility operator have the ability to set that chlorine threshold to trigger that flushing event and specify how long that flushing event shall occur or when it needs to shut off, correct?
Correct, yeah. So interesting unit.
Yeah, it's certainly some of the promises of more intelligent automated flushers out there, and it's something to be really excited about. It sounds like perfect fit for some of your most challenging spots at your utility. So definitely a great story for automation and your smart flushing program over there. Thank you for sharing. So we'll appreciate you sharing your story. We'll go into our next poll question. And so it is our second and final poll question. So we look forward to the audience's response. And the question is, have you considered or would you consider an automated flushing program? Our answer choices are A, yes, we have already deployed devices in the network. B, yes, we've previously considered automating our flushing program, but have not taken action. Or C, we have no experience, but it is something we are investigating. So we'll see where the team is on their journey here shortly, and see how we are comparing to some of our peer utilities across the nation. Looks like we've got our results. And so, yes, 25% have already deployed flushing devices in their network, and 15% have considered but have not taken action as of yet. And a majority of the folks are considering this. There's something worth considering, and hopefully this webinar and some of the facts and background that Harold have shared and Chris has shared about the city of Plano will be helpful to you as you investigate your flushing program more carefully here in the future. So thank you for responding to our questions.
So Tim, let me ask you a question then. As you stated earlier, you came from a different industry, but you've got over 20 years of experience in technology. How do you see the advanced technologies that you're used to in other industries being utilized in our industry in order to improve water quality and help out in the distribution challenges that I talked about and that Chris talked about? How do you see things changing?
Yeah, it is a great question, and it's really a great opportunity to be able to apply some of that technology experience to a meaningful industry like the water industry, where we're actually helping our communities. And first and foremost, as a technology professional, we must think of our customers first. And it's only until we really understand our customers' pain points until we can actually pick the right technology. And often a lot of users of new technology products rightfully have a fear that sometimes this technology might be difficult to use, especially if in the past you've had a bad experience with some new technology, some new program out there. But in reality, technology should make our lives much simpler and not more complicated. And so for me, as a technologist, I also need to think about the user experience. And the user experience is really everything. Technology can work for us, be more productive, as referenced by Chris, if we pay attention to the user experience and some of the workflows that the utility has to address in their day-to-day jobs. Just for example, think of how much of us turn to a secured online payment platform to purchase groceries during the height of COVID, or how do we think about how Uber has changed our way that we travel when we're on business travel. So whether it's creating a shopping experience or making travel easier, there are many advanced modern technologies that came together behind a very straightforward application interface. Then there is the added benefit of using data to create insights and influence future decisions. So I really do think that now it's time for the water industry to take its turn in a digital transformation. A lot of industries have. As I mentioned, retail, but also banking, finance, as many more. And at Mueller, we're investing in technologists and user experience experts to make the technology work for water specialists. It's an opportunity for the technology teams and water specialists to solve complex problems together, and they're very meaningful problems, and it's great to be a part of. Our team of experts here at Mueller can integrate and develop a sensor network and integrate that into the distribution infrastructure that allow the water specialists to make an informed decision in their day-to-day job. We can store the data on a secure platform to inform strategic planning, or we can utilize that data in real time using some of the latest microcontroller technologies and edge technologies to operate operational tasks to provide a reliable real-time response to the network conditions. Ultimately, we want a more intelligent network to make teams more productive and deliver clean water to our communities. So kind of bringing it back to the flushing use case that we were speaking about today, technology and automation can provide remote-based monitoring, like that smart system installed at the city of Plano and the industrial park. Remote-based monitoring, monitoring for key water quality parameters like chlorine or turbidity, pH, temperature. We can do scheduled time-based flushing and event-based flushing. As Chris mentioned, that smart flushing device has the ability to trigger based on a chlorine residual. And then as an added benefit, we have the ability to collect a comprehensive data set for benchmarking and strategic planning. So we can continuously improve our operations at the water utility. Ultimately, water utilities will benefit from improved visibility, reduced operational and maintenance expenditures, as Chris spoke to earlier, reducing a crew of 10 down to 2, so the other 8 individuals can work on other important tasks within the compliance division, or reducing the expenditures on equipment that appears on a truck and sometimes can go missing. Also have the ability to control the non-revenue water with automated flushing systems. And the neat part, which I've learned from you, Harold, and Chris and others, is that with these automated flushing programs, you can actually flush more often, improving the water quality in the distribution network, while reducing the overall water discharge. So you can reduce your non-revenue water that way, and cut down on your customer complaints, which we all know that whenever a customer calls, it costs us money to support and take care of that customer, and it's our reputation and our city council's reputation on the line. And then finally, I guess the last benefit that I'll speak to here as we wrap it up is, these automated flushing programs can allow utilities to meet internal and regulatory and consumer expectations. So we're really looking forward to being part of this industry, applying technology, the most advanced technology that's out there. Cloud platforms, hybrid type platforms that integrate with your existing systems. They do exist, and they have been embraced, and they really do open up for some new opportunities, even opportunities that we haven't even envisioned yet, because we're just not that far down our journey. So very exciting times to be part of this water industry. So thanks for the question, Harold.
Sure.
Thanks, and Tim. With that, we come to the close of our panel discussion, and now we want to open it up to answer your questions. So we'll turn it over to the Q&A part of the session.
Okay, wonderful. Thank you so much. And thank you all for your insights and expertise on advancing water quality initiatives through monitoring, analytics, and mitigation. We'll go ahead and start with our first questions. Here's a question for Harold. How do auto flushers keep from having backflow/cross connection issues? And do they have internal backflow preventers?
Yeah, they do. Great question. And so it depends on the model. There's a variety of automatic flushing products in the market. Many of them use an air gap for your backflow prevention. Others use a double check valve or an RPZ. Anything that's below ground is going to have a double check valve in it. As we mentioned, there are a lot of your new communities of underground utilities. Many of those don't want another pedestal sitting in the front yard, so therefore you'd go with an underground flushing system, and that underground flushing system would have a double check. In fact, the little screen image you see here right in the middle with the coil, that is a flushing device that sits below grade and has a double check valve built into it.
Excellent. Okay, and the next question is actually for Tim. Joseph would like to know, are there any revenue collection challenges due to the pandemic? What are the costs of water there and now handled by water utility and the customer?
Yeah, so I mean, obviously, the pandemic has changed the way we live and we work, and there has been challenges with utilities revenue is not as high as they were prior to the pandemic, as industrial usages have decreased. Of course, the cost of water continues to be the top of mind and costly for us. And you know, reducing our cost at the utility and providing technologies to reduce the cost at the utilities, we hope that can bring in that revenue versus cost delta that exists there, and was further exacerbated by the pandemic.
Okay, excellent. Thank you so much. And we have another question. I'll just send this out to the three of you to see. What do you do about a tree system? Is it too expensive to modify a tree system with closed loops as opposed to adding a multiple flushing points?
Chris, would you like to answer that one, or you want me to start and then you can chime in on it?
So I just wanted to be a little bit more clear on the question here. They want to compare the price of adding multiple flushing devices to putting in a loop. Was that the question?
Yeah, I'll read it again. What do you do about a tree system? Is it too expensive to modify a tree system with closed loops as opposed to adding multiple flushing points?
I would say adding multiple flushing points. You're already going to have them. I can imagine if you have a tree system anyways, and then adding a loop is just a massive undertaking on a construction end of it, and engineering and drawings and approvals and permits, and then the construction itself. So, I mean, I can imagine adding multiple flushing points would be, you know, from a cost standpoint, much more effective, in my opinion.
Yeah,
I don't know how big the system is, though. You know, I mean, it's hard to say if it's, you know, a very small system, and then that might be different than a very, very large system.
Yeah, and I think I agree completely, Chris. And I think another thing to consider here between a branch and loop system is that even though obviously there's going to be significant construction costs related to looping lines, there is a bit of a misnomer in that, thinking that when you loop a line, you've eliminated your dead ends. When you loop, depending on the pressure on both sides of that loop, you can end up with a dead-headed area of water in that loop, and therefore you still need something to remove that slug from that line. And a lot of times utilities will flush from a hydrant somewhere on that loop in order to remove that slug. So again, you've reduced some of the dead ends between a branch system and a loop system, but you haven't fully eliminated that potential to have a dead-headed area of water somewhere in that line.
I agree, because once your water goes bad, you can sit there and circulate it all day long inside that system, or it can just sit there if nobody's using it. So if it's a loop and nobody's using it, it doesn't matter. It's still just a bad water sitting in the pipes.
Yeah, we had a situation down in St. Petersburg a few years ago where a utility, it's right around the last recession, and they had built a neighborhood and built it for 200-300 houses, and there were probably 20 houses built in the neighborhood, maybe 10 of them occupied. So pretty sizable water line, 12-inch main in this area. They ended up looping the system there, but they had to have two automatic flushers opposite ends of this loop in order to continue the rotation and move that slug along and get it out of there, because, you know, obviously the slug, because of the pressure, was ending up around the 5 or 10 houses that were occupied. So they're getting a lot of customer complaints in those areas.
Excellent, great answers to that. I appreciate that. And I think I'm going to send this next one up to both of you also, to see how you would answer that. Does the automatic equipment account for the amount of water wasted in flushing? That's the first part. How does it deal with dechlorination requirement? And how do water utilities deal with the water wastage? And I can read those over. We can start from the top.
Well,
So
go ahead, Chris.
go ahead, Harold. I was going to ask you to repeat the first part of the question.
Oh, okay.
Okay,
Yeah,
perfect.
if you would, Billy, if you would repeat that for us one more time, then.
Will do. Does the automatic equipment account for the amount of water wasted in flushing?
Yeah,
Go ahead,
Chris.
Harold. I've got some comments on it as well.
Well, thinking about the word waste, I know that's what the general public sees, and I think Chris, you brought this up a second ago in that when you have to send a crew out there, we have to do our job. We have to turn that water over, and it sometimes does require us to go to a hydrant to be able to do it, especially if we need to scour. And the general public does see that as waste, but it's really not waste because if we don't turn that water over, they're going to be calling and complaining about the water quality. So I don't necessarily equate the water we're flushing as being wasted, especially if we can direct that water to something. If we can send it off to a swale, which takes it out to navigable waters, we can take that water, put it into a storm pond that can be pulled out for irrigation, or maybe we can charge an irrigation system with it. We're not truly wasting it. We are putting it into a reuse type of situation. As far as dechlorination is concerned, the devices that I know of all have, they come standard with dechlorination systems built into them. So any water that's being flushed through those systems mixed with a slurry of dechlorination chemical, and then that slurry is then ends up dechlorinating all the water coming out of that system. Chris, jump in there for me.
Okay, as far as the first question, number one, when that water goes bad, it's got to get out of the pipes. You got to get it out of there. I don't care if you're getting it out with a hydrant or you're getting it out with an automatic flusher. Either way, it's got to be taken out of there. It's unsafe, or it's going to become unsafe at some point. So the cost, I don't know, cost of water versus cost of the device. I don't know if it's really comparable. It's just how you're getting it out of there. And then I would equate it probably more to staffing savings and equipment savings than trying to compare it to the water wasted or lost. As far as the dechlorination part of it, yeah, Harold's right. All the ones that we've put in and purchased, we require dechlorination during flushing for all types of flushing in our city, even if you're flushing for putting a new line in service or to test a new line, we have to dechlorinate everything. So everything that we put in is capable of holding a certain amount of dechlorination tablets or whatnot, however you decide to dechlorinate. They do have to be checked periodically. You have to make site visits, but one person can probably do what you would have 5 people doing, just running around checking and replacing dechlorination tablets, however often they need to be replaced, and that just depends on how much you're flushing. Obviously, if you're flushing a massive amount of water, then you're going to be checking those tablets a lot more periodically than you would if you're just running it once a week or once a month. And I think there was a third part of that question, but I don't remember what it was.
The third part of the question was, how do water utilities deal with the water wastage?
Well, like Harold said, it's not waste. And like I said, it's once that water's starting to turn bad, you got to get it out of there. There's not much reviving it. Once the residual's gone and the chemicals are out of there, it's time to get rid of it. So it's just, it goes down in the storm drains, goes out back to the water source, unfortunately.
Yeah, many utilities will meter the water. They'll put a meter in line with the flushing system so they can account for their non-revenue water. And then that's certainly a good idea. Even the devices that go on fire hydrants will oftentimes have a meter put on them so that, again, you can account for the water being utilized. And, it's important to, Chris made a point in his discussion earlier that tends to get glossed over a lot of times, and that's that public perception issue. I've worked with utilities in California. One in particular was in putting in automated systems because their crews were having stuff thrown at them, physically having cans and stuff thrown at them. They didn't want to expose their crews to that kind of stuff anymore, so they automated. By automating, you can flush in the middle of the night where you're not drawing down on somebody's pressure while they're trying to wash the kids or wash dishes or whatever they're doing. You can turn the thing, you can avoid flush times with automated systems that may not be able to be done with by sending crews out, because a lot of times except for when we have our issues, which always happen after hours, but we try to keep everything between the working hours when possible. That may not be the best time to be flushing. So by automating it, you can flush in the middle of the night when you're not causing any customer issues for somebody.
And back to that real quick, we do meter all of ours, by the way. Everything we hook up is metered.
Excellent. That is wonderful. And I have a question. This one is for Harold. This is from Chris. Chris would like to know, we are looking into the smart auto flushing devices, but trying to install a cabinet in a urban case can cause issues with residents. Have you looked into creating a smaller profile flusher?
Actually, that is something that the company is looking to do, is create a smaller profile. Our company does have one smaller size. There are some limitations based on where you're going to put it. Like I said, you do need to know where you're going to install these things, because you may have to bring AC to them. You might have to put a solar panel on them. As you said, the size of the device could impact a community. If you don't have a lift station or somewhere that's nearby that you could put it where it's not going to obstruct somebody's yard, that's something to certainly consider. So it is in our plans to, we are in working on some lower profile devices. So that is certainly a possibility. Tim, I don't know if you want to talk more about that technology.
Well, certainly, as you said, I think there's an opportunity there for to reduce the footprint of some of these devices as technology evolves. And as you mentioned, stay tuned.
Yeah, fortunately, as we progressed with smart technologies related to flushing, the size of the components, your analyzers and everything else, have also become smaller and less power hungry. So as that has transitioned, we have also transitioned with that technology. So some exciting things are happening in this realm, and like Tim said, stay tuned. We're right on the cusp of some things.
Excellent. Okay, great. And Tim, we have a question for you. Are there cost-effective systems for small villages in cold country, say less than 100,000 GPD?
Well, we certainly do offer automatic flushing units for warm climates as well as cold climates. So the answer is yes. And we would love to hear about your specific requirements and see which is the right flushing unit to fit your needs.
Yeah, some of the below ground technology that's out there does have smaller line sizes. So therefore, the internal piping is smaller than the internal piping in some of the devices that go above ground. That's really for serviceability. And therefore, the benefit to a smaller utility on a technology like that is that it is going to flush less water, but you're going to accomplish the same benefit by turning that water over frequently. You're just not going to be drawing down on your, if you have smaller line sizes that you're trying to flush, you're not going to draw down on the pressure on those lines as much. You can control your flows and accomplish your water quality improvement.
Okay, excellent. We've got another one for Tim, but would like to leave it open to anybody else who would like to answer as well. With 900 dead ends, plus 50 to 70 additional flushing points, how does one decide which blow-offs or hydrants need to have an automatic device installed? No one can afford to have 950 devices installed.
Well, maybe this perhaps is a better question for Chris. at the city of Plano. So maybe Chris, if you could kind of take us through a little bit of your thinking there on, which dead ends did you prioritize?
Okay, so the dead ends that we prioritized are actually chosen by engineering. They're built in. We're speccing our new water lines going in on dead end mains to have one of these devices put in on the end of it. So we don't actually make the pick. The ones that are left for us to flush manually every month, they're just left for us to flush. And we'll find the staffing and figure it out and make it happen. As far as the other devices go, there's a temporary device that we're also using, which just basically attaches to a hydrant. And then you turn it on, lock it, and it has the same capabilities as the bigger units, except that you can move it to different locations. So, we're purchasing a handful of these just to move them around to different areas and utilize them, not as stationary units, but as mobile units, and move them to the areas where the water is the worst at certain times. You might have one area that has bad water at a certain time of the year and not so much at another time of the year. So you can grab a few of those units, take them to the different area and hook them up and use them all over the place rather than having stationary units installed. But like you were asking about picking the best spots to put the stationary units. That's all water. That's where that water aging map and a water model of your system comes in super handy. And then really just knowing your high maintenance spots.
Yeah, if you haven't invested in a water age and water quality map like Plano has, one thing you can do is certainly look at if you're tracking your water quality complaints, you can certainly rely on that to identify where some of these dead end points are. And the beauty of these automated systems is it's not totally localized to where that flush point is. A one flushing system like a smart flushing system, you can cover about a mile and a half of line. And the way that Plano and Chris's team has developed this area for their flushing system is that they're going to be able to phase the flushing so that when a slug is picked up when something's picked up that's out of spec from the smart flushing system, they'll be able to time their other flushers so that that slug can just be moved through that system and eventually moved out of that system. And we've had utilities. There's a military base in California. It's got a 34-inch main. It used to serve as a alternative landing strip for the space shuttle. And in order to turn that water over in that 34-inch main, they installed 10 automated flushing systems, and they phased each one of them one after another so that as that bad water slug got picked up, it would continue to dissipate as much as it could from one unit. Then the slug would move down the line, it'd get picked up by another flusher. By the time it made it to the end, they'd gotten rid of the majority of that bad water. So there's a lot of things you can do. Obviously, nobody's going to be able to afford to put one on every dead end point, but it's ideal to know where those hot spots are. Obviously, it's costing you a lot of money when these customers keep calling in. It's bad for publicity also. As you well know, as you know as well as I, they've probably got the telephone number for the mayor or the city council person or county commissioner, and every time that they got an issue, they don't call you, they call them, and then they call you, and that becomes a problem for you guys. I've been out to dinner with many of you, and at 8 o'clock at night, you're getting phone calls. So, that's where these automated things can go in and cut down on some of that. I'm going to call it a hassle, but it's not really a hassle, but it cuts down on the issues for you guys.
Excellent. Okay, great. Well, we'll start with you on this next one then, Harold. Ivan would like to know, are automatic flushers tamper-proof?
All the automatic flushing systems that I'm aware of do have some form of security on them. Your non-smart or your traditional flushers are typically keyed. They may have a key and a hasp type of locking system on them. Those keys are typically a unique design. Your intelligent smart flushing systems, they do have security on them, and you know, they have. And Tim would be a better expert to talk about that level of security when it comes to the technologies. Tim, if
So
you
these
want to.
are keyed. The ones that we have installed are keyed with a special key. I don't know if you
Perfect.
can see that. It's not something you're going to pick up at the hardware store, but they're
Right.
all keyed. All of ours are. Even the temporary units that we've got, the actual nut that screws onto the nipple of the fire hydrant has a set screw. You tighten the set screw, and then there's this locking device that slides over the knuckle, and then you put a lock through here, and that protects that set screw from being taken out. So yes, everything we've purchased has theft control and it's lockable.
Perfect. Well, Chris, we'll start with you for the next question then. How to operationally handle chloramine/chlorine interface during maintenance events?
Say it one more time. Sorry.
Sure. How do you operationally handle chloramine/chlorine interface during maintenance events?
That's where that water model comes in handy, and directional flushing. And basically, when the chloramines come into our system, we're trying to get them out, spread out as fast as we can to the far reaches of the system, and then shut everything down, let them do their work. And then when the chlorine maintenance period's over and they've done their job, the free chlorine's done its job, then it's time to get the chloramines back in the system. But we rely heavily on that water model to focus on the areas that it's going to get the water where it needs to go fastest. And it's real similar to peak flushing times. You're going to have the same areas, flush the same areas that you would flush during peak water quality issue times. Those are going to typically be the hardest to get that chloramine or free chlorine, whichever phase you're in. That's going to be the hardest spot to get those two as well. So a lot of those spots kind of are the same on both ends of the spectrum.
Okay, excellent. Thank you. And this question is actually directed to all three of you. Our older flushers have been causing problems with the hydrants, i.e. they won't shut off completely, weep holes constantly running, etc. Do you have any suggestions? We've been fighting with our maintenance department about it.
Yeah, with any of these devices, especially when they're attached to a fire hydrant, it's critical that before you put it on the hydrant that you flush that hydrant. Go ahead and do a quick flush, blow out everything from it. I know none of us have rocks and stuff in our system, but every once in a while a rock does come through. And so it's important to flush that hydrant, move that any kind of debris that might be in there, move it out, then attach your flusher to it. Because inside the flusher, as many of you have probably taken them apart, there's a control valve inside there, and those control valves have the ones I'm aware of have an EPDM single piece diaphragm in it. That diaphragm is protected. There is a screen in there that keeps some stuff from going through, but larger debris can sometimes tear or puncture a hole in it, and that could be your problem. It could just very well have a puncture in it. Another thing that can happen, especially on these hydrant models, is that there's a rim inside the valve that the single piece diaphragm will sit down inside of. If you get dirt or any kind of grit, and it really doesn't take a whole lot of grit, that gets up underneath that diaphragm anywhere, and it doesn't seat properly, you can get a leak by. So it sounds like you might have a situation where you probably will have to take the device apart, take at least get to the valve, take the top cover off the valve, and inspect the diaphragm in there to see whether you might have a hole in it or perhaps there's some grit. If they're fairly old, it may just be time to change out the diaphragm. It's a fairly inexpensive change out. And it's something that I would probably recommend keeping one or two on the shelf most of the time because it's not unusual to go to a hydrant and have some debris go through it and tear a hole or puncture it. You are typically flushing a little higher velocity on your hydrants, a little higher flow rate, And you can get a relatively small pebble becomes a pretty good projectile going through that valve. So I would definitely take a look at the diaphragm in that situation.
Okay, and I'm just going to ask one last question and then we'll head out. Given today's security concerns, are these systems well protected from hackers? Can they be updated to the latest security standards?
So I'll take that one, and certainly security is a big concern, and we are designing all the next generation automatic flushers to the next standards, and really what we're doing is we're looking at the threat the threat and the attack surface, and then developing a layered security approach to prevent a hacker to use your system against you. Some of these automatic flushers that we've been speaking about today are certainly connected just through Bluetooth capabilities, and so it puts minimal risk to your system.
Okay, excellent. And I want to wish a special thank you to Tim, Chris, and Harold. I hope you all have a great day. We appreciate everything you've done. And that does conclude our webinar on advancement of water quality initiatives through monitoring, analytics, and mitigation. Before we go, I want to thank you for joining the webinar today. And please don't forget to participate in the survey immediately following the webinar. Thanks again.
Thank you.
Thank you.